My talk will be about enterprise data management with a flexible graph platform. So enterprise data management, I will shortly try to explain what I think enterprise data management is or should be, and then demonstrate or show you our approach of how to manage data in an enterprise with a flexible graph platform, which is, no surprise, Structr. It's our system we developed, started 5 years ago, 6 years ago in the meantime. We're based out of Frankfurt in Germany, as I said, and it's an open source project, and it's based on an embedded Neo4j, and in the future not only embedded, but also using the new Bolt driver with Neo4j 3.0. So enterprise data management. It was not the initial motivation of creating Structr to create an enterprise data management system. But so actually we started as Neo4j itself. We started with a content management system. But then we saw that you have much more options or possibilities with a graph as your data model to limit it to the scope of a content management system. So we finally, on maybe not the final stage, but we're now focusing a little bit on enterprise data management. Yeah, and as I said, I want to just give you the context about what we think enterprise data management is about and how to handle that. So these three words, enterprise, data, and management, we'll try to explain a little bit what we think are the most the major challenges in an enterprise. So in the first place, you have many people in large companies, many departments, and many processes, because each department or each user groups has their own process or processes. And the same things, a little bit related to that, is about the data. You mostly have heterogeneous data. That means that you have very complex and very different looking data structures. Sometimes data is even very unstructured. Think about email or data in documents or in just hidden in files. You could also, of course, have very well-structured data in databases already. In an enterprise, you typically have distributed data silos or data structures. So you don't have all the data in one place, which is one major problem, as we will see. And you mostly have different semantics for your different data, because that's directly related to the different use cases and different areas you handle data in your enterprise. And some of the data is not even supported by IT. That means it's on paper or in Excel sheets or in the heads of the people. And now trying to manage this data, typically you create many IT systems. In a large company, you typically have dozens or maybe even hundreds of IT systems. And for each different use case, you start with one IT system, and then another one comes, adds up to the complexity of the overall IT landscape. And then you have product owners, which are guarding their data and their applications and their processes. You have different user groups, which are not necessarily overlapping very much, but they have, of course, overlaps. You have overlaps in this landscape. So this is not really enterprise data management. This is more or less department data management, I would call it. So this is mainly a problem in many companies. So what's the solution? You have to integrate the data. And this is where the problem starts. So one scenario is you have no automation. Of course, you can integrate data and processes by just letting the people enter data manually or print out data or just talk to each other or writing emails. This is common practice, and it causes lots of friction, of course, because it's very slow and it's error prone. And oftentimes you end up having an Excel-based shadow IT. I call it shadow IT because people are smart, and Excel is, in the beginning, it's easy to use, and they just start creating their own, starting with data sheets, some spreadsheets, then some formulas were added, and some macros, and so on. So it's really, I mean, it's the reality that you have kind of complex Excel sheets and try to get rid of a 20-page Excel sheet with kind of very sophisticated data model in it. And there are even projects migrating Excel applications to, I don't know, different technology. That's surely not the best situation in a company. And even worse, what about the processes? It's very hard to map processes on or with that kind of infrastructure or model. So what do? You try to integrate the different IT systems or even Excel applications, and you create interfaces. Or what do you have to do to integrate the different IT systems? You want to connect the systems and let them interact automatically. You have to create interfaces between all the systems. You have to map the data structures between all the different systems, which is very difficult because you have different formats and different semantics of your data. You have to specify the exchange rules, like which system talks to which other. Is it pulling data from one system or pushing data to another, and so on, which is the primary or secondary system in such an exchange process. And if you connect, in theory, if you connect each system with each other in a bidirectional way, you end up having n times n minus 1 interfaces, which is an exponential growth. So the more IT systems you have in a company, the worse the situation gets. One partly good solution, or one solution, I think the idea came up 20, 30 years ago, was to create integration hubs. Create a central place where you exchange data. You have to, of course, still specify interfaces, but only between each IT system and this integration hub. There are different technologies like middleware systems or an enterprise service bus and so on. What you basically do is you reduce the number of interfaces from an exponentially growing number to a linearly growing number. Like in this case, if you count each direction for itself, then you end up having a 2 times n number of interfaces between the systems. The downside is you introduce just another complex system, which is very, very hard to maintain, because when a system changes, you have to, of course, change the interfaces to the integration hub. And basically, it's more or less dumb middleware, just exchanges data. Of course, you have you try to integrate that the smartest way possible, but mostly the most simple system in this context in general limits the intelligence you could put into your integration hub. And the major problem is the processes still live outside this integration hub. It's very, very hard to really integrate processes from different IT systems within your company into one integration hub. So the integration hub is more or less a data exchange and not necessarily something to streamline and integrate processes. So what's the best approach, or what is the approach we think is the best approach? It's to create a unified system. So what does it mean, a unified system in this context? A unified system, I try to symbolize that with the different colors and the different elements here in these images. There's one central system which has all the data sources integrated very tightly, which has the processes integrated and a unified data model. And the different departments talk to this central system in a very special way. So what do you need? A unified data model. This is a major task for itself. It's not very easy. Any one of you who was in the talk given by Dr. Weber from Schleich, he already talked a little bit about what it means to unify a data model. You have to find a common taxonomy and so on. So this is really hard work. And then you can start integrating the processes. You have processes defined in one place. And then you can start replacing IT systems with components of your central system and get rid of this Excel culture, which is, from an IT perspective, a good thing. And instead of having a complex, monolithic IT system for each department, you can create micro-apps. Micro-apps, what do we mean by micro-apps? Micro-apps are the equivalent to microservices. Which microservice is more on the backend side, and the micro-app is something which is a user face. It's a user interface which is very dedicated to a very limited and special use case for a limited group of users, but it connects to the same backend system. So it's kind of easier to create just a small user interface with a very simple UI than just create a very complex department IT system. Yeah, they connect to a shared backend. And you only have to connect the systems you cannot replace or you don't want to replace. Like if you have a very important SAP ERP system in place, then it's maybe not a good idea to replace this. But you can limit the scope of the SAP system to the scope it was designed for and it's good in. So SAP, for example, is not the best system to map and store all your enterprise data. So people do that, but we don't think that is a good idea. So for example, Schleich, our customer Schleich, introduced at the same time, or started last year, I think, introducing an SAP system, but they introduced it in a very slim scope, or very narrow scope. And so it was a little bit unusual for the SAP people that their system was not the primary system for the enterprise data. But I think the customer Schleich did really well with the decision to use a system I'd like to show you right now, instead of having an SAP system taking over the company. So what you have to do, and we are here at Graph Connect, and of course what you have to do and what the approach is from a data modeling perspective is to take all the different already existing data models within your departments or within the IT systems of your departments and just connect them. And it's really as easy as in this picture. Maybe the graph is a little bit more complex, but this is actually what we did. And that's basically what Dr. Weber showed us in the morning. And now it makes really sense because one department you can create a micro app which is maybe only about the marketing information, which is maybe in the upper left corner. And in the bottom right corner, you have the manufacturing information. And now, out of a sudden, they are connected, and you can answer very complex questions just by a graph traversal. That's the basic idea, which is, of course, at Graph Connect not that new for you or to you. And so what is the system we use, or what's the technology we used? This is basically what we did with Structr, the graph application platform. What we had to do was to unify all the different models, like, for example, an entity relationship model. It's an RDF Structure-based model, so more or less a semantic model, which was also in place. Or you have software business logic living in software, which is also a graph. And you have user interfaces and applications and data interfaces and so on. So what we did, I think that was the most important part that we did, was to create a unified central data model within Structure. Just before we go to the demo, I'd like to just step through some of the major, I would say, characteristics of what Structure is, because this is the question people always ask when they come to our booth. What is Structure? And it's difficult to explain because it's a lot. I think we always start with the user, because the user is the most important components. But it's not nice to call a user or a human a component, but maybe a yeah, I don't know. But yeah, starting with the user, it's very important to create nice looking and good working applications. And so Structure is an application development framework or environment where you can very easily create mobile and web applications, and we call them in this context micro apps. It has an integrated content management system for storing static and also dynamic resources and media assets. As Dr. Weber also mentioned, at Schleich we could completely replace an existing media asset management system just by connecting the documents to the other graph nodes. It has also document management capabilities for file storage, including full text search, CMIS, content management interoperability services. It's an enterprise integration standard for content management systems. Or the classic old FTP protocol, or you can even interact with your file data via SCP or the SSH protocol. It has a very important component to connect to other systems, or you can even write your own front-end application against this dynamic REST API. And you can define in a very flexible way just by modifying the integrated schema, create JSON views. So you can use Structure as a document database, creating arbitrary documents or in arbitrary formats of your graph data, which is a very important or a very interesting use case for itself. Central component, which I will also start the demo with, is the integrated visual schema editor, where you can interactively model your own custom data model or schema. And last but not least, some simple data management capabilities with a table and a graph-based editor. And all this is based on or embeds Neo4j. And yeah, this is the complete picture of the architecture of the application. It's a transaction. You have transaction safety, which is very important. And you have a large connected graph. And by using the Neo4j Enterprise, you have the operational features you need in an enterprise. So it's an enterprise-ready solution. What are the major benefits of this technology or this platform? I would say, and this is already in the title of the talk, I would say, flexibility is number one. You can start small and then just extend the data model and the application step by step. For example, you can start with one department and just create a small data model and a small micro app just for a few people. Then connect or integrate another IT system or create another micro app or integrate another application. And the interesting benefit, I think, is instead of having days or weeks for each change in a complex application, you have round-trip times for change requests about minutes and hours. And this is really the way we worked at Schleich. Sometimes in the morning, some business user said, okay, I'd like to have this function changed, and then we discussed what changes were needed in the data model, what implications would that change have in the context of the overall architecture, and what changes we had to be applied to the data to the user interface. And after a couple of communications back and forth, we just implemented that at runtime in the running system. And in the afternoon, they already could test and give feedback. And typically, even a more or less complex change like an expert search or implementing a new kind of specially filtered list or something was implemented within 1 day. And this is really a game changer for the users in an enterprise, because they are not used to that round-trip times. So typically, they wait forever. So they just stop articulating wishes and change requests. Number 2 is performance. And performance out of one perspective, from a developer perspective. Of course, from a user perspective, it's nice to have complex searches just finish in about 1 second. This is what you expect from a web application. If you can't deliver this kind of performance with a web application, then the user acceptance really diminished. But from a developer perspective, it's very interesting, because you don't need to optimize your access path up front, which is what you typically have to do in a classical approach with relational databases or with an integration technology. You really need to know upfront, before you design the system, who accesses which data and how many elements or how many items do I have of this or that kind of data in the database. So you have to you can create indexes or materialized views and so on. From you all know maybe what I mean by that. So you don't need to optimize before designing the application or building the application. You can do that while or even after having built the application. And this was, now we're getting closer to the demo. This was the initial data model when we imported couple of gigabytes RDF OWL dump into the system. And then we, over time, we refactored the data model in the running, on the running system. And after that, and some reshuffling and sorting out, it looked like that, much clearer. And we also helped the customer to really get a better understanding of their data model, because this is the only data model in the whole enterprise or in the whole company. It's not exactly true, because it's ongoing work to extend and refactor the data model. We don't have to go through all these steps of redesigning and so on. We just add a new node. I will just demonstrate it in the software, not in the live system, but on a demo system here, how it worked. Yeah, and then the micro apps could, for example, look like that. So a micro app is more or less a web page, an interactive web page with forms and tables, very classic. But could also look like a mobile application with a very limited set of elements, which people, for example, in the manufacturing department have their iPad or iPhone just laying around, just hit one button or enter one number, which is a completely different kind of application. But we could do that or implement it with the same technology. Okay, so let's jump over to the demo, hopefully. So this is just a local Structr server. I just started with an empty database, and after login, you land somewhere, for example, in the users and groups. I don't know if it's you have the screen behind. So as I said, I first jump to the schema. So it's a visual schema editor where you can just add a new type by typing a type name or a class name. For example, in this context, we want to store products, so I create a new type called product. Let me move that away. And for example, component. Yeah. And a relationship, we just call it contains. And depending on what your actual data model or your reality is, you have a one-to-many or or many-to-many relationship. So now you just created a small data model, and I'm slowly running out of time, but this is basically the way you just create this data model. You can add attributes, you can also add methods, and for each connection here, the system automatically creates a so-called remote attributes referring to the connected nodes over these relationships. So based on this data model, Structr has an already automatically configured REST server, and then you can just jump over to this pages section. This is the application builder, and then you can wire the data, or you can wire the application components to your data. So I'm running out of time. Please come to our booth, then I can show you more. And we have a team of 6 today, so I think we have enough time. And just give me one more thing. So small announcement, small company, small announcement. As of today, Structr 2.0.0 is available. You can just go to our download page or web page and download that. It's a really big step for us. It's a second major release. The last major release was 1.0 was in 2014. So there are lots of new features and performance and stability improvements in Structr. So yeah, I think I have to finish now. So questions, please join me outside. And thank you for listening.